So we start today with g of x equals square root of x, and we want to find g of 4. So pretty straightforward. We should be good at these by now, just using function notation, plugging in. Square root of 4 is 2. So g of 4 is 2. And then what we've been doing with composition of functions, we've been using that output as the input of the second function. So that means we're going to find f of 2. So f of 2 is 2 plus 8. That means f of 2 equals 10. So in reality, what we did was we were saying f of g of 4 equals 10. That's kind of the idea with the composition of functions that we were talking about the last couple class periods. Okay, just to give you guys a little warm up here, I want you guys to try these 4 problems here where you're going to practice your composition of functions. The first thing you might want to do, it helps me out personally, is just to rewrite it so I can see which one's the input function. So in this case, g of 6 is the input function. So it helps me rewrite it that way a little bit first. So I want you guys to try those 4 problems, A, B, C, and D now. Take a couple minutes to work on those. All right. And let me know if you have any questions on them at all, but that's your little warm up today. Try problems A through D. I've got parts A, B, and C posted here, so you can check your work and see how you're doing on those ones. So remember those composite functions, figure out what the input function is first. So on part A, for example, we start with g of 6. And then when I find that output is 4, I'm using that output as the input of the outer function. Kind of weird, a lot of things with outputs and inputs, but that's the idea for these composite functions. So hopefully we got f of g of 6 equals 14. I hope I didn't make any mistakes while I was solving it myself. But that's what part A should look like. Part B, I got g of f of 6 equals 11. Part C, f of 6. So the first thing I did on part C was I said, hey, f of 6, I already solved that on part B. That's 20. So I don't need to solve that again. Just say, hey, that's from part B. Cool. And then f of 6, 3 times 20 plus 2. And then I got 62 for f of 6. I'm just inputting the same thing twice. Okay, and the last one, part G, says g of g inverse of 6. G of g inverse of 6. So if I need to do, my input function is g inverse of 6, the first thing I need is an equation for g inverse. So I have to do that before I can even solve this. So first I would say y equals x over 2 plus 1, and then I'll go ahead and substitute x equals y over 2 plus 1. Subtract 1 from both sides. Multiply both sides by 2. And there's my g inverse. My g inverse of x is 2, I'll distribute 2x minus 2. So there's my g inverse equation. Now I can go ahead and say, let's do g inverse of 6. G inverse of 6 is 12 minus 2, 10. And once I have that, now I can do g of 10, because that's the outer function. And I get 10 over 2 plus 1. G of 10 is 5 plus 1. G of 10 is 6. So g of g inverse of 6 is 6. All right. So that's the trick for part D. If I give you, hey, find this function composed with like its inverse, the first thing you have to do is you have to solve for the inverse, unfortunately. So we had to start by doing that. Get the inverse equation, and now I can plug in and solve. All right, that's the idea with composite functions versus inverse functions. So the next thing here, I ask you to go ahead and find the inverse of each of these following functions. So find the inverse of f of x, find the inverse of g of x. So I want you guys to go ahead and do that now. We'll go ahead and start by saying y equals 5x plus 10, x equals 5y plus 10. And then the second one, y equals 1/5 x minus 2, x equals 1/5 y minus 2. And I want you guys to go ahead and solve these, and then put them back as write them back as f inverse and g inverse respectively when you get them. So take a minute to do that. All right, so hopefully you were able to get these things simplified. So the first one, we get x, we subtract 10 from both sides. Then we get x minus 10 equals 5y. Then we can divide both sides by 5. And we get x minus 10 divided by 5 equals y. And then the last thing I'd want to do is rewrite it as, I'll write it as f inverse of x, since I've got y by itself now. But I also have, since I have x minus 10 divided by 5, I want to break that down into two separate parts. So I can say x divided by 5 minus 10 divided by 5, or I can rewrite that as 1/5 times x. I like writing it as 1/5 times x more, because then I can see the slope is 1/5. And then 10 divided by 5 happens to be 2. So that's what I'd end up with for f inverse of x. For g inverse of x, I'm going to start by adding 2 to both sides. And I have 1/5 times y. So I want to multiply both sides by 5/1. And then I get 5 times x plus 2 equals y. And then I'll write that as g inverse of x. And then g inverse of x is 5x plus 10. That's the idea for finding f inverse of x and g inverse of x. So what do we notice about these two functions? What do we notice about f inverse of x here? What's that look like? 1/5 x minus 2. Any thoughts? It should look familiar, because that is g of x. And then the same thing here, when you do g inverse, you get f of x. So what's happening here is f inverse of x is the exact same thing as g of x. That's a fair thing to say. It's also fair to say that g inverse of x is the same thing as f of x. So what it turns out is, when we do this, f of x and g of x are inverse functions, or are inverses of each other. Okay, so that's the kind of the key takeaway here, is sometimes you'll have one function that's an inverse of another, and you can prove it by showing that they are inverse functions. I asked you to do that on one of the homework assignments. It was where we had to do the temperature. We were converting from Fahrenheit to Celsius, and on that specific homework assignment, it was simply prove that they are inverses. So when you find the inverse of the Fahrenheit equation, you should get the Celsius equation. And when you find the inverse of the Celsius equation, you should get the Fahrenheit equation. That's exactly what's happening here as well. All right, so you would have seen that problem on your homework. So now I ask the question, what happens if we compose two inverse functions? We compose two inverse functions. So that means for this one, we want to find f of g of x. So that means we're going to take f of 1/5 x minus 2. So I take this 1/5 x minus 2, that's my g of x function, and I'm substituting that in as my input now. Instead of having the input as x, the input's now 1/5 x minus 2. And I can go ahead and distribute that 5. 5 times 1/5 is x. 5 times -2 is -10. So I get x minus 10 plus 10, which just becomes x. Okay. For part B, g of f of x. I'm going to do g of 5x plus 10, 1/5 times 5x plus 10 minus 2. This time, the 5x plus 10 is the input instead of just a regular x. And then I can go ahead and simplify this. So g of f of x is 1/5 times 5, that's x. 1/5 times 10, that's 10/5. And then I get x plus 2 minus 2. Well, x plus 2 minus 2 is x. So that's one thing we'll notice when we do a composition of functions. I can use compositions to prove two things are inverses. So we can say down here, if f of g of x equals x, or g of f of x equals x, then f of x and g of x are inverses. If f of g of x equals x or g of f of x equals x, then we've just proven that they're inverses. That's a second method to prove two functions are inverses. So the first one is to find the inverse function. That's what we did in part A up above. And we found that f inverse of x is equal to g of x. And then we found that g inverse of x is equal to f of x. That's the first method to prove inverse functions. The second method to prove inverse functions is you take a composition of functions, put one inside the other, and you get f of g of x equals x. Do you get g of f of x equals x? All right. I want to take your attention back up here to problem D, g of g inverse of 6. G of g inverse of 6 equals 6. What if I asked you to find g of g inverse of 10? What do you think the output's going to be? Go ahead and type that into the chat if you think you're on board with what I'm saying here. So if it was right now it's g inverse of 6 equals 6. What if I said let's make the input 10 instead? What do you think the output's going to be if you're doing a function composing it with its inverse? So what is g inverse of 10? What do you guys think? Any guesses? Yeah, you're exactly right, Titus. That's that easy. It's 10. Okay, that's the idea. So if you can find a function and its inverse, whatever you put in, it should just equal that number for your output. So in this case, f of g of x equals x. I could say f of g of 1 equals 1. F of g of negative 72 equals negative 72. G of f of 361 equals 361. It doesn't matter what I plug in, I should get that exact same number as the output. That's what inverses are when you take a composition of functions. So that's what example D was up here. So we did all this work to find the inverse, and then we plugged it in, and then we plugged it back into the original function, and we got all the way back to 6. But now that we have that knowledge, we can just say, hey, well, this would just equal 6. I know that because the functions are inverses of each other. So you could save yourself a little bit of work there if you can state that, oh, these are just inverses of each other. Awesome. Good. Okay. Last thing today, just a little bit of review practice from quadratic functions. So I have f of x equals this quantity x minus 4 squared. I want you to represent the function and its inverse in each of these forms. So first create a table of values of the function its inverse, then the graph, and then I want you to list the domain and range of the function its inverse, and then finally in the equation form, write the equation of the inverse of this quadratic function. Okay, so take a couple minutes to work on that. I'll give you about 10 minutes to work on that, and then we'll wrap it up for the day. Okay, I've got the answers written here so you can take a look at them. So just make sure when you're doing the table, you're just plugging in the x values, figuring out what the y values are going to be, what your outputs will be, and then you can switch it. So swap the x and y values to make the inverse table. And then when you're graphing, make sure you label both the graphs so I can tell which one's the function or which one's the original and which one's the inverse. So I just labeled them f of x and f inverse of x, so that way we can tell. Okay. Are there any questions on identifying the domain and range or writing the equation? You could write the equation a different way as well. I'd be perfectly fine if you wrote it as plus or minus square root of x plus 4, just as long as it's clear that the 4 is not inside the radical. That's the only part you have to be careful with when you're writing it this way, which is why I like to write the 4 in front instead. So that way it is clear that the 4 is definitely not inside that radical. All right, any questions on any of this part though, just this review practice?